Hi, welcome to Automotive Appreciation Part 10. In this course we cover engine cooling systems, air-cooled engines, liquid-cooled engines, thermostats and compartment heating. Although engines have improved a lot, they're still not very efficient at turning chemical energy into mechanical power. About a third of the input energy provides useful motive power and a considerable amount is converted to heat. About a third of the energy passes out the exhaust pipe and the remainder is absorbed by the engine components, causing them to heat up. The cooling system manages this waste heat by transferring it to the surrounding air. Water-cooled engines use a liquid to remove heat fast enough to keep temperatures low so the engine can survive. Marine engines use the volume of water to directly cool the engine, while air-cooled engines use a large volume of air and a fan to maintain engine temperature. If an engine is operating at less than optimum temperature, power and efficiency will suffer. Emissions will rise and components will wear faster. Too hot, it will overheat and seize. We now take a closer look at different cooling systems. Vintage cars relied on thermosiphon cooling. As hot water heats up, it expands, becomes lighter, rises and has a natural tendency to flow upwards. Hot coolant leaves the top of the engine block and is passed to the radiator, where it is cooled by the fan before returning to the bottom of the engine. Circulation was powered by convection alone. In an air-cooled engine, large fins are employed to conduct heat away from the engine. Cooling rate can be controlled by varying the size and spacing of the cooling fins. Since air is a relatively poor coolant and is only 1/10 the thermal conductivity of water, a large fan blows air through a duct to remove heat from the fins. The system is simple and lightweight. Coolant does not have to be changed and there is no engine damage due to freezing. However, it can be difficult to achieve accurate cooling, low emissions and low noise. The original Volkswagen Beetle used this system and it is still popular on motorbikes. In a modern water-cooled engine liquid, a pump circulates water through the pipes, heat is absorbed from the block, thus cooling the engine. On startup, the water bypasses the radiator to allow the engine reach operating temperature quickly. When the water heats up, the thermostat changes position and allows hot water flow to the radiator or heat exchanger. An electric fan controlled by ECU cools the radiator, and hot water is allowed flow to the heater core, which is used to heat the passenger compartment. A fan supplements the flow of hot air to the passengers. In the radiator or heat exchanger, the coolant flows through the thin tubes and transfers heat from the coolant to the metal cooling fins, which provide an increased surface area, allowing the heat to be dissipated to the surrounding air. We now take a closer look at the thermostat. With the cold engine, the water is directed back to the pump, bypassing the radiator. This prioritizes the engine and compartment heating. The stat comprises of a chamber filled with wax. When the engine is started, the water heats, the wax melts and expands, thus exerting a force on the pin and changing the valve position, allowing coolant to flow through the radiator where it is cooled. Later, when the engine stops and cools, the valve will close. A stuck valve will affect the operation of the complete system. The radiator pressure cap is used to pressurize the system to a specific overpressure, which raises the boiling point of the coolant. It also acts as a pressure relief valve, preventing damage to hoses and connections. When water heats up, it expands. A spring-loaded valve in the cap will release the pressure, and the excess water is allowed flow to the expansion tank. Later, when the engine cools down, a negative pressure in the cooling system sucks the water back through a vacuum valve in the cap. For the interior heating system, coolant flows to the heater core located under the dashboard of the car. An electric fan assists with the movement of air, while a blend door is used to direct flow through the heater core when required. Vents direct air to the windscreen area for maintaining clear glass, to the passenger area, or to the floor area as required. The head gasket provides a seal between the block and cylinder head. If the engine overheats, the head can warp, releasing the seal provided by the gasket. If coolant or combustion gases leak, the gasket must be replaced. This is often referred to as a blown head gasket. In a modern engine, the cooling system is controlled by the electronic control unit. A thermistor measures the engine temperature, and with this information, the ECU controls the radiator bypass and cooling fans. The compartment heating is also controlled by the ECU. On some cars, the inlet air vents are closed at high speed to improve aerodynamics. Similar to other control systems, if a problem is detected, the driver will be alerted via an engine warning light. While water is abundant and has the capacity to hold a lot of heat, it has some undesirable effects also. It has a maximum density at 4 degrees Celsius and expands if temperature is either increased or decreased. If water in an engine freezes, it can burst the block or radiator. Water boils at a relatively low temperature, which can create steam bubbles, which act like an insulator, and freezes at a temperature experienced in some countries. To increase the boiling point, the pressure in the system is increased, and to lower the freezing point, a chemical antifreeze is added. Coolant, antifreeze or ethylene glycol also contains rust inhibitors to prevent corrosion and has added lubrication properties. We hope you learned from automotive appreciation, and perhaps you may be interested in our other training videos.
Chào các bạn, nếu các bạn cảm thấy clip của mình hay thì hãy like và subscribe cho mình nha. Cảm ơn các bạn.